Hey all, welcome to Homeschool. Hope everybody are doing fine. And welcome back to Class 11 Physics series. I am with the last session on a chapter, Motion in Straight Line. So we are going to complete the chapter with this video. And please do watch my previous video before watching this, because this is the continuation of previous video. See, in my previous video, I started discussing about the graphs related to motion, right? So we mainly have three different graphs that we need to study. One is XT graph, that is position time graph. Second one is VT graph, that is velocity time graph. And the third one is acceleration time graph. So we have discussed everything about XT graph, and in today's video we will talk about VT graph in detail and also some basics of AT graph. Okay, see, VT graph is the most important graph, guys. From VT graph you can come to know many things. Even this is a very important tool for solving many toughest problems. You can come to know so much information about a motion of an object looking at VT graph. Okay, so let's understand what actually we mean by VT graph, and initially we will see how VT graphs look for different kinds of motion. Okay, see, we all very well know that always, the horizontal axis is your T axis, that is time is plotted in horizontal axis, and in vertical axis we will take velocity. Okay, fine. See, if you have a VT graph of this kind, okay, say the first type of a graph it is. So if a graph, okay, or if you have a straight line parallel to t axis, that is time axis, then what does it mean? It means that, you see, imagine the object is here, right? And this is time 1, 2, 3 seconds, 4 seconds, 5 seconds, 6 seconds, etc. And this is velocity 2 meter per second. Velocity's unit is meter per second, right? So 2 meter per second, 4 meter per second, 6 meter per second, 7 meter per second. So what do you understand from this graph? You see, at time 1 second, velocity was 6 meter per second. At 2 second, velocity is 6. At 3 second, velocity is 6. Say at every time instant, the velocity is same, right? Object's velocity is same. It's not that object is at rest. Many of them will get confused here. You know what? In XT graph, in my previous video, I told if the XT graph is like this, it means that object is at rest. But this is velocity time graph. It means that object's velocity is same, right? It doesn't mean that object is rest. See, object is moving with constant velocity. What does this mean? Okay, so what is the meaning of this line parallel to t axis? It means that object moves at constant velocity. Okay, so that means it's talking about uniform motion. It means uniform motion. Okay, so this is really a very important. It means that velocity is constant. Okay, so it doesn't mean that object is rest. If you have this particular line in XT graph, then it means the object is rest. So here don't conclude that object is at rest. So this is where you have to be careful, guys. Okay, so this is one type of graph. And coming to the next type of VT graph, you see V in this axis and T in this axis. Say if I have a line something like this. Okay, see here, as the time increases, our velocity is also increasing, right? So, and it means that this is a graph for uniform uniformly accelerated body. Accelerated body. Okay, so this is not a constant velocity. Okay, so velocity is not constant here. Here velocity was constant, but here velocity is not constant. Okay, and you know what, here v is positive, like v is increasing and a is also positive. Okay, so just there is a connection with a and vt graph, guys. You can find out acceleration from vt graph. Okay, so a means acceleration, so just as of now remember this much. Say if a line is straight line, okay, so in this direction, you know, v is positive and a is also positive, right? So this is a kind of a straight line. You will get it for uniformly accelerated body. Okay, so acceleration is uniform, acceleration is constant, but not velocity. Okay, fine. And now if you have a graph something like this, okay, so here what do you mean by that? It is the body shows negative acceleration. Okay, so in this graph a is negative. Okay, so here a was positive and here a is negative, and this is also a graph for uniformly accelerated body only, because you are getting a straight line, so it means it is moving with uniform acceleration. Okay, if it was non-uniform acceleration, you will get a curve. Okay, so when you get a curve in vt graph, okay, it means that acceleration a is not uniform. A is not uniform. Okay, so for non-uniform motion, that is if the acceleration is not uniform, you will get a curve. If the acceleration is uniform, you get a straight line always. Okay, so straight line like this means a is positive, v is also positive. Straight line something like this is a is negative, that is acceleration is decreasing, that is the object is slowing down. Okay, so that is what the actual meanings that you must know from the graph. So this is a general idea. Okay, so it's very important. When you have a line parallel to t-axis, it is with constant velocity, that is this is the graph for uniform motion, and non-uniform motion but with constant acceleration. This is a positive acceleration, and here it means a negative acceleration. And if you get a curve, it means that even acceleration is not uniform. Okay, so this is a very basic idea. And now let us understand what is the importance of VT graphs. I mean, what information that you can come to know from VT graph. Just like from XT graph, we can find the average velocity and instantaneous velocity, right? So the slope of XT graph is what? The average velocity value. So here, the slope of VT graph will talk about acceleration. So we can able to find out acceleration from VT graph, and also we can find displacement from VT graph. So two important things we can calculate from VT graph. One is acceleration, the other one is displacement. So let us see how to identify that. So let me write it first. So two important things that we can find out from VT graph, that is acceleration. We can find acceleration, okay, and we can also find displacement of an object. From VT graph, we can find the displacement of an object. So first, let us talk about how we can find acceleration. Okay, say for example, let me take this as a VT graph. Okay, so time on t-axis and v on this vertical axis. Say for example, if this is your straight line you got, okay, so positive velocity, and you see this is what your initial velocity, okay, so this is initial velocity u, and this is your final velocity, I can say v, right? Fine. And you know what is the slope of this line? Slope of this line is this much. So this is the slope of this particular line, right? Say this is tan theta. How do you calculate tan theta here? Tan theta is nothing but, what is this? This difference, right? So this difference divided by this difference, this value, right? So let me take, this is 0, this is 1, 2, 3, 4, 5, okay? And this, let it be 2, 4, 5, 6, 7, okay? Fine. So how do you calculate the slope here? Slope is nothing but tan theta, right? So tan theta or slope is one and the same. So this, what is this? This is nothing but v minus u, right? So this value, final velocity minus initial velocity, right? So v minus u divided by time, right? Final time, let it be t2 and this one let it be t1, okay? So t2 minus t1, okay, will give you the value of slope, right? And what is this? Change in velocity. V minus u is what? Change in velocity divided by t2 minus t1, right? So time interval. So change in velocity by time is what? Acceleration, right? So what is acceleration here? Slope. Slope value is equal to acceleration. If you can find the slope of this line, definitely you will get the value for acceleration. So here, can you tell me what is the value for acceleration here? What is V? V is 7 minus U is what? 2, right? So divided by, 5 minus 0, that is 5. So it is 5 by 5, that is 1 meter per second square, right? So this is what your acceleration, right? So just find the slope and you get a value. Just like in the xt graph, we found the velocity, right, with respect to a slope. So velocity is nothing but the slope's value. Similar to that, here the slope's value is nothing but your acceleration's value. So acceleration is what? Change in velocity by time. So change, this is the change in velocity, okay, divided by change in time, okay. This length, this difference divided by this difference between the 2 points will give you the acceleration value. Okay, so this is the way of calculating acceleration, right? So now let us look at one question on how to figure out the acceleration from a graph. See guys, let's understand the question. See the VT graph and find acceleration from t is equal to 0 to t is equal to 5. And the second question, find instantaneous acceleration also. So just acceleration means what? It is a average acceleration. Okay, so acceleration between 2 points is what? Average acceleration. And acceleration at a particular time, at an instant of time, is called as instantaneous acceleration. Okay, so both can be found in a similar way. Just put a slope, just find the slope, and value of slope is nothing but the value of acceleration. Okay, fine. So what they are asking you, see, just observe the VT graph here. So, V in this axis and T on horizontal axis, right? Say, all this is one straight line, right? So initially the acceleration was decreasing. Actually, it is decelerating, right? And again from this point, it is, the acceleration increases, and from here again acceleration increases. Okay, so everywhere you will see sharp increase and decrease of acceleration, right? So what they asked you to find out, acceleration from t is equal to 0 to t is equal to 5. T is equal to 0 to t is equal to 5. Okay, so that means between this point, let me call this point as A, this point as B, this as C, this as D, this as E. Okay, so you have to find the acceleration between this point and this point. So what you will do, see 0 to 5, right? So if you join A and E, right? So this is the slope. This is the slope. This angle you have to find, right? So just observe the purple color lines. Say this is your triangle. You know, this is your slope. This angle you have to find. So how do you find this angle? This difference divided by this difference, right? So this is your delta V, and this much is your delta T, right? So what is delta V? This minus 30 minus 0, right? So I'm not writing it elaborately. Say, as you know, you have studied in previous video also how to find a slope, right? So this is what? This is V. This is V, right? And this is U, right? So V minus U. V is how much? 30. 30 minus 0. 30 minus 0 divided by time difference is how much? From 0 to 5? It is 5. 5 minus 0, that is 5, right? So it is 30 by 5. So that means 6 meter per second square. Okay, so that is your answer. Fine. Coming to the answer for second question, guys. They asked you to find instantaneous acceleration at 6th second. So where is 6th second? That means here. At this point, time is 6. So here you put a line, that means at this point, let me call this point as I. At this point you have to find the acceleration. Okay, it is just similar to average acceleration. If I would have asked you to find average acceleration, what you will do between this point and this point? You know, I'll just put a line here. This I'll extend, right? Say slope of this line will give you average acceleration, right? Say here the average, if something is a straight line, if you have to find the average acceleration, then it is equal to the instantaneous acceleration at any point. At any point. Okay, so between E and F, okay, if you have to find instantaneous acceleration at any point, it will be equal to average acceleration between E and F. Okay, so this is what you have to be very careful. Say, I made this clear in my previous video also. So when something is a straight line, say finding acceleration means it's between 2 points, or finding velocity means it's between 2 points, right? Say you get the average velocity or average acceleration. Acceleration in case of Vt and velocity in case of Xt. Okay, so if something is a straight line, you know, the instantaneous velocity at any instant in this line between EF will be equal to average acceleration between E and F. Okay, so they asked you to calculate instantaneous acceleration, but I am calculating average acceleration between E and F. That will be equal to this instantaneous acceleration. Okay, so how do you calculate instantaneous acceleration at 6th second, right? At 6th second. So instantaneous acceleration at 6th second is equal to, see, this divided by this length. This is the change in velocity, right? Say, what is the final velocity now? Final velocity is this V. Here the initial velocity is V because the starting point. I'm just considering about E and F. So E is initial velocity and F corresponding to the F, the line drawn is final velocity. So this difference is how much? It is 40 minus 30. 40 minus 30 divided by what is the time gap? What is the time gap between, you see, E and F corresponding to T axis? It is 8 minus 5, right? So 8 minus 5. So that is 40 minus 30 is 10. 8 minus 5 is 3. So you would get your answer 3.3 meter per second square. Okay. So this is how from VT graph you can find average acceleration or instantaneous acceleration. So the method of calculating average acceleration is similar to instantaneous. See, if I would have asked you to calculate acceleration between E and F point, this is how you would have calculated, similar way. But here, between E and F, at any instant, if you want to calculate acceleration, it is similar to average acceleration only between E and F. Okay, so this is really very important. And when, as long as the graph is straight line. But if it is a curve, okay, if your graph is a curve, then I'll tell you to find the acceleration between A and B. Then what you would do? You would just connect A with B, and this is what we call secant, right? So slope of secant will give you value of average acceleration. But here, if I tell you to find the instantaneous acceleration at this point, which is coming between A and B, then at this point you have to draw a tangent, and slope of tangent will give you instantaneous acceleration. Okay, but as long as if it is a straight line, your average acceleration is equal to the instantaneous acceleration at any point between E and F. Between this, average acceleration between E and F will be equal to instantaneous acceleration at any point between E and F, right? But if it is a curve, average acceleration is not similar to the instantaneous acceleration between any 2 points. Okay, so average acceleration you will find by finding slope of secant. Instantaneous acceleration you will find by drawing tangent at the point where you have to find the acceleration, instantaneous acceleration. Okay, so this is really very important to understand. So now we understood how to find acceleration from VT graph. It is just by calculating the slope between the 2 points, right? Slope of a line. And now let us try to understand how to find the displacement from VT graph. See guys, finding displacement from VT graph is very simple guys. It is just area covered under VT graph is displacement. If you can find the area under VT graph, then that is the value for displacement. Okay, so it's a very important tool that you can use for finding displacement normally. Okay, so it's nothing but area under VT graph. VT graph gives displacement, right? So let us see how we can find that. You see, imagine we have a VT graph, okay? V in this axis and T, this is a T axis, horizontal axis, and let the time be, this is 1 second, 2 second, 3 second, 4 second and 5 seconds. And this is 2 meter per second, velocity in meter per second, right? So this is 2, this is 4, this is 6 and this is 8. So imagine I have this straight line in VT graph. What does this mean? That the object is moving with constant velocity, not at rest. Very important. This means that object is not at rest, it is moving with constant velocity. Okay, so imagine this is point A and this is our point B. Okay, so if I ask you to find the displacement between A and B, okay, so my question is find displacement between A and B. So how do you find? So you will have to just do area covered under these 2 points. Find area covered under these 2 points. Say if I have to project A on x-axis, that is on t-axis, okay, so here I get, and B if I project here. So this is what the area covered, right, between A and B. So this is area covered between A and B. So this area which is equal to displacement. Displacement. Okay. So what is this? What is this shape? It's nothing but a rectangle, right? So what is area of a rectangle? Area of rectangle. This is a rectangle, right? So area of rectangle is equal to length into breadth, right? Length into breadth. So what is the length here? T-axis, this much. This much is the length, right? So 1, 2, 3, 4 minus 1. So this much is this time gap, on the t-axis. This is what makes your length. So it is 3 into breadth. The breadth is this much. This much. Okay, you have to check the velocity difference 0 to 6. That means 6 meter per second. So 3 6 12 meter is the displacement. So area of rectangle itself is displacement, okay, of an object from A to B. So what is your displacement here? It is 12 meter. Okay, so the straight line, it can be a straight line, it can be a curve, or whatever it is, whatever may be the graph you get, just area covered under graph if you can find, then that itself is the value for displacement. Okay, so this is how we will find displacement from VT graphs. Okay, so for example, imagine if your VT graph is something like this. V on this axis and T on horizontal axis. Say if this is your VT graph. Okay, so this is object A was having a velocity of this much, and let me call it as 2, 4, right? 6, 8. Okay, and object has moved from A to B. Okay, so if I ask you to find the displacement, this is a VT graph. Okay, if I asked you to find the displacement, how would you find? So just this area under AB. What is the area under AB? This much. Okay, so this much is the area under AB. So this is area under AB. Okay, fine. So this much, this area you are going to find out. Okay, so what is the shape, guys? It is a trapezium, right? So your answer is, just if you can find area of trapezium, then that itself is the value for displacement. Okay, so how do you find, what is the formula for finding area of trapezium? It is half into sum of two parallel sides, right? Sum of two parallel sides, right, into height, right? So what is sum of two parallel sides? Say what is this side and this side is a parallel, right? So half into this side is how much is the length here? This side, it is 4. Okay, this is 0 to 4, and another parallel side is this. So what is this much? 0 to 8, right? So 8 plus height is what? This much time. So if it is 1, 2, 3, right? So 0 to 3, that is 3, right? So how do you calculate this? How do you calculate? Half into, or 8 plus 4 is what? 12 divided by 2 plus 3. So that is 1 6. So 6 plus 3 is what? It is 9 meters. So 9 meters is the displacement that you will observe here. Okay, so 9 meters is the area of trapezium you found. So 9 meters is the displacement in this case. Okay, and imagine if you have a graph of something like this. Okay, say just if you have a graph like this, okay, then how do you find? Say this is V and this is T. So it's actually a discontinuous motion. Motion is not continuous. You know what? Body was started with this velocity. Okay, so at this it started with this velocity, it moved with constant velocity, and then suddenly velocity is changed and it's moving with different velocity, but it's constant, right? So motion is not continuous, guys. It's not a continuous motion, right? But then VT graphs are possible, something like this. So how do you calculate displacement in this case? So it's just as simple as this. Say it is this area, right? So it is area of this part plus area of this part you have to do. Area, this is a rectangle, this is another rectangle. So area of this rectangle, so your displacement S is equal to area of this rectangle plus area of rectangle 2. Okay, so this is how you will calculate displacement in different situations. So if a graph is something like this, it's just a rectangle, area of rectangle you're finding. And if a graph is something like this, trapezium shape, and trapezium's area, if you can find, you will get the displacement. So you may have graph something like this, right? So it is just our displacement is nothing but area covered under graph is displacement. Okay. So now let's look at few questions so that you will get more clarity. See guys, on a board I have given 3 questions. Say graph is given, you have to find the displacement. Okay, all 3 questions is about finding displacement from VT graph. So here graph is given, here also graph is given. But here in a question, some information you have to find the displacement or distance. So first you need to draw a graph and then find. Say, let us talk about them one by one. Say this graph is given, you have to find the displacement of an object. Okay, you see the graph, VT graph you can observe here, right? Say there is one parallel line, right? It's parallel to t-axis, and another line parallel to t-axis, but it's a discontinuous motion. Say this type of motion we will call it as discontinuous. It is not continuously moving. Okay, somewhere here and there some stops are there, right? But anyway, so our target is what? To find the displacement, right? So how do you find the displacement? Area under graph. Okay, so area of this line, okay, that means this area and this area, right? So hope you understood what I'm talking about. This area and this area. This is one rectangle, this is another rectangle. Okay, let me call this as rectangle A, rectangle B. So here for displacement, you have to find area of A rectangle plus area of B rectangle will give you displacement. Okay, so what is the area of A rectangle? Length into breadth. Okay, so what is the length here? This much. This much is your length, right? So what is your length? 1 minus of 2. That means you can understand this is 1, this is 2, this is 3. 3 units is the difference. So this much is your length. That is 3. 3 into, breadth. Breadth is how much? You see 0 to 20, right? So 20, right? So 3 into 20 plus area of B rectangle. So what is your length? Length is 1, 2, right? So 2 units difference. So 2, or you can do like this, 3 minus 1, okay? Into breadth is how much? This difference, right? 0 to 40. 40 minus 0, that is 40, right? So this is 60 plus 2 for the 80, right? So you will get around 140 meters, right? So what is your displacement? S in the sense displacement. So your displacement is 140 meters. So hope you are getting an idea how to calculate displacement, right? So if the graph was like this is how you have to calculate. And now you look at this graph. Here also you have to find the total displacement of an object. Okay, you see here this is a constant velocity. And here again it is also discontinuous motion. Okay, so this is a line for constant velocity and this is another line for constant velocity. Okay, so just area of this, area of this, area of this and area of this you have to add. This is a rectangle A, this is a rectangle B and this is a rectangle C. Okay, so what you have to do? Area of A plus B plus C you have to do. But you see, okay, say area of C, you will get it in a negative sign. You know, anything below this t-axis is negative, anything above the t-axis is positive for velocity time graph. Okay, so for velocity time graph, so anything that is above the t-axis is positive, anything below the t-axis is negative. So here when you calculate the area, you will get it in a negative sign. But you may be wondering, area can never be negative, right? Area can never be negative, correct, but that negative sign is talking about the direction. Okay, so negative sign is only for the direction. And anyway, area of this and area of this will get cancelled, right? Okay, see how they will get cancelled, you will understand now. Just observe. Area of A is how much? Length into breadth, right? So what is the length here? 0 to 2. So 2 into breadth is how much? 30, right? Okay, so plus B. B's area is how much? So this is the difference of 1 unit and this is a difference of 0 to 20. Right? What is this? A difference of 1 unit into what is this? 0 to minus 20, right? So minus 20. So what do you get here? 3 2s are 60 plus 20 plus, and you see here you are getting minus 20. Okay, so this rectangle's area is minus 20. So area is minus 20. Minus sign is telling you that this rectangle is there below the t-axis. It is there in minus axis. Okay, and anyway this and this will get cancelled, right? So what is your answer? Answer is 60 meters. So that is your displacement here, right? So when you have something like this, looking at this you can understand this get cancelled with this. So now what is the area? Area is only this much. So that much you can calculate and that is the answer for displacement. Okay, so you can analyze that just by looking at the graph, right? Fine. So this is how you can find out, the displacement from a graph. And now look at this question, read it carefully and try to find the distance traveled by bike. Okay, so they are actually asking distance traveled by bike. But see, you have to plot a graph also here. A bike starts from rest, accelerates at 3 meters per second for some time and then decelerates at 20 meters per second square till it comes to rest. If total time is 20 seconds, find distance traveled by bike. Say on using a formula you can find out, not a big issue, but still you just observe with the help of a graph how am I finding distance traveled by a bike. Okay, so with the given information I am plotting a VT graph. Distance I need to find out, so I am plotting a VT graph. Okay, very good, fine. See, a bike starts from rest. Okay, that means a bike is starting from here. So when something is at rest, T is equal to 0, V is also equal to 0. So this is the starting point of a bike. Okay, so this bike from rest accelerates at 3 meters per second. Accelerates. Accelerating means what? Increasing velocity. So you will get a straight line, something like this. Okay, so what is its acceleration? That means this line's slope, they have given it off. This line's slope is 3 meters per second square. Okay, then decelerates at 2 meters per second square. Decelerates means what? Negative velocity. That means the object is slowing down. Okay, so decelerates, it is decelerates till it comes to rest. Okay, decelerates, decreases velocity until it comes to rest. Okay, it travels, and what is this line's slope? Acceleration means what? This line's slope. Okay, so what is that? 2 meters per second square. Okay, so all that will happen. So object coming at this point, again from this point to this point, this will happen within a time gap of 20 seconds. Okay, so this is the graph that I plotted. And what I need to find out, find the distance traveled by a bike. That means displacement. Okay, if I have to find the displacement here, I just have to find out the area of this triangle. Okay, so what is the area of triangle? Say here distance S is equal to area of triangle. Let me call this as point A, point B and point C. Okay, so area of triangle ABC. Okay, so area of triangle ABC is how much? Half into base into height, right? So this is the formula I have to use. Okay, so here just if you can calculate this, you will get distance traveled by a bike, guys. Half into base. Base is what? Base is this. Okay, base is this distance. This you know, no, time gap. X-axis is what? Time. Time gap is how much? Moving from A to C. It is 20 seconds. So base you know. So here base value you know, that is 20 seconds. And what you have to find is height we don't know. Height is what? This is your height, right? This is your height. So this is the velocity. We don't know. Height you see 0 to this point. If you can know this velocity, this value if you can know, you can just substitute in the place of h and you can calculate the area. So for finding h, so this is your height, right? Okay. And you just observe this triangle. Just observe this triangle. This triangle. Carefully you observe. Slope is given. Okay. So slope is given. And consider this as some v. Consider this as some v. Then what is this? You know, we all know, right? V by something is equal to slope. Slope is given, that is 3, right? Let me call it as t. Okay, so this is t, this is t, and we know t plus t is equal to 20. Okay, right? So this is t, this is t. T plus t is equal to 20, and v by t is equal to slope, right? So v by t is equal to 3 meter per second. So what is t? T is equal to v by 3, isn't it? So what is this? Is let it be t1, let this be t2. Okay, so t1 is how much? T1 is v by 3. Okay, plus like that only find t2. Okay, consider this triangle now. This is the slope. Okay, this by this is equal to slope, right? That is v by t2. T2 is equal to slope, isn't it? So now what is t2? T2 is equal to v by 2, right? So T2 is equal to v by 2. So v by 3 plus v by 2 is equal to 20. Can't you find out the value of v here? So what is the value of v? So what is the LCM I can take here? 6, right? So 6 in the numerator, what do you get? 2v plus 3v is equal to 20, right? So 2v plus 3v is 5v is equal to 20 into 6. So 5v is equal to 120, right? So v is equal to 120 by 5. So v is equal to how much, guys? V is equal to 20. 5 ones are 5 twos are 24, right? So v is equal to 24 meter per second. So we got the value of v. So that means height. V value is nothing but what? Height, right? So height we got to know, that is 24 meter per second. So base of this triangle is time. They gave it in question, 20 seconds. And height we didn't know, but using this logic we found the height 24 meter per second, right? So if you substitute, half into base is 20 seconds into height is 24. So 1s are 10s are, right? So it is 240 meters. So what is the displacement? What is the distance traveled by a bike here? It is 240 meters is the answer, right? See how plotting a graph has helped us to solve this problem very, very quickly. Usually if you go on a normal logic, if you want to find any other formula to solve this problem, it's a very difficult thing. Okay, you can't find this problem that easily, but you see, very quickly, very easily, you can get the answer for this question with the help of a graph. So everything is there in understanding a graph. So graphs will help you to find the solutions easily, and you must definitely know how to plot these graphs. Okay, so that's all about finding displacement from VT graph. So now we are going to a last concept, that conversion of VT graph into XT graph, XT graph into VT graph. If you know XT graph, you can plot VT graph. If you know VT graph, you can plot XT graph. Okay, so this is a very, very important idea one must have about. Let's learn this. Guys, this is really the most important topic. Concentrate. So you must know few fundamentals here. Suppose I'll give you XT graph. Okay, so your XT graph looks something like this. So what do you mean by this? XT graph. See, position is constant. That means object is at rest. Okay. So when the object is at rest, what does this mean? The object is not having any motion. So its velocity is 0. So for this graph, you will not get any VT graph. You can't plot any VT graph. So if I have to convert this XT graph into VT graph, it is not at all possible. Okay, so you can't plot VT graph. Okay, you can't convert this into VT graph because object is at rest. Okay, object is at rest. Fine. And now this is our first point you have to remember. Coming to second point, in case if, let me take it quite bigger one, if our XT graph looks something like this. Okay, so what does this mean? This means that uniform motion. Yes or no? We studied XT graphs in our previous video. I explained everything in a detailed way. So you have to watch that. So XT graph, when you get something like this, what do you mean by that? It is a uniform motion. Uniform motion means you have constant velocity. Constant velocity. Okay. So this one, if I have to convert into VT graph, how does a graph looks like? So if you have this straight line in XT graph, then in a VT graph, you get the line parallel to t-axis. Yes or no? So what do you mean by a line parallel to t-axis? Velocity is constant. Velocity is not changing. Actually, this line in XT graph is also same meaning, no? Constant velocity. Right? So what I wanted to tell you here is, okay, if a straight line in XT, okay, then that line, how do you represent in VT? You will represent that line as, okay, you will represent that line as parallel to t-axis. Okay, where? In VT graph. Say it's better if you can write all this and keep. This one will definitely help you a lot. Okay, fine. Now coming to third situation, guys. If in a XT graph I have a curve, okay, if in a XT graph I have this curve, what do you mean by this curve? See, curve in the sense what? Velocity is not constant. Velocity is not constant. Okay, so velocity is not constant. Velocity increases and A is positive. A is increasing. Okay, so velocity not constant. A is increasing. So if you have this kind of a curve in XT graph, then you have to show that in VT graph as a straight line. Okay, you have to show it as a straight line. Okay, so you will have a straight line with increasing velocity. Okay, increasing velocity means what? Here velocity is positive and A is positive. velocity is positive, A is positive. Okay, so remember, if you have this kind of a curve, it means A is positive. See, in VT graph, increasing acceleration, see, velocity increases. See, from here to velocity increases. When does an velocity can increase? When you have acceleration increasing, when you have acceleration positive. Okay, so this is what the meaning. And now, coming to situation number 4. In case in your xt graph, okay, if you have a curve like this, see here when you have a curve like this, okay, but here when you have a curve like this, then this particular curve you have to represent in VT graph as like this, decreasing velocity. You see, curve, downward curve, it always indicates velocity. V is negative, okay, or I can say it in a better way, V is decreasing, velocity is decreasing. Okay, if V is decreasing, A is negative. For negative acceleration, this is what you will show. Okay, is that clear? And what about here? What about here? See, velocity is constant in the sense what? Here A is equal to 0. So in this VT graph, if you have this horizontal line parallel to t axis, means A is always 0. Okay, so but in a VT graph, when you have a line increasing, right? So when you have a positive slope for a line, A is positive. In a VT graph, when you have a negative slope, say velocity is going this way, that means definitely when you calculate a slope, you will get a negative value. If you get a negative value, A is negative. After all, what is slope? Here, in a velocity time graph, slope value is nothing but acceleration value, right? So this is how you have to carefully think of. See guys, in the fifth situation, in case in the xt graph, if I have a curve something like this, okay, upward parabola, right? So, upward bowl or whatever it is. So, how do you represent this in VT graph? How do you convert this in VT graph, guys? You see here, guys, from negative side, the object is coming and it is reaching to t-axis, right? So, again, from negative side only, I need to come. And you see here, if this is a curve, if this is upward bowl curve in the sense, see, if it is an upward curve, you get a positive velocity. You get a straight line like this. You don't get a straight line like this. You will get a straight line like this. Okay, so upward. So it's an upward curve, right? You get a straight line, but it should be from negative. From negative, it should touch 0 at t-axis. See, this point is 0, right? At t-axis. Okay, so it should touch at t-axis and then go that way. From negative side, it should start. So this is the negative side of VT graph. Okay, so from here I'll start. Something like this it should go. Positive velocity, positive acceleration. So here A is positive. Okay, with positive acceleration, because the curve's shape you must see. If it is upward bowl, okay, if it is just a shape of a bowl, then a straight line must go this way. Okay, velocity must be increasing, acceleration must be increasing, right? So velocity value has to be big. Okay, and if it is inverted bowl, if the bowl is something like this, if a curve looks something like this, then the straight line must go in opposite direction. Velocity must decrease. That's it. A must be negative. Okay, so these are the fundamental idea one must remember while converting xt graph into VT graph or VT graph into xt graph. Okay, so this is a basic idea. With this idea, let us see one example how we can convert xt graph into VT graph. See guys, on a board I have an xt graph. Okay, so you should convert this into VT graph. So can you all try? Can you all pause the video and try yourself? Okay, you can just pause the video and try yourself with the basic idea that I gave you, right? So now with 5 points, all the basic ideas I gave you, if the xt graph has how to convert it into VT graph, right? If you have a parallel line, how you have to represent in VT graph, if you have a straight line, if you have a curve, right? So keep that idea and pause the video and do this. Okay, so after trying, you just observe this. You see, it is starting at rest. In the xt graph, the object is starting from rest. Okay, so I have to, in my vt graph also, I have to start from rest. Okay, from rest to this point, you observe it's a upward parabola, right? It's a curve, it's a upward parabola. So if it is in the xt, if it is a upward parabola, then how must be your what must be the way you represent in vt? You will represent as straight line, right? Positive velocity with increasing velocity. Since it has started from rest itself, you know, from point, okay, let me mark this as point A, point B, point C, point D and point E, right? So my object from rest, it's a curve, upward bowl, right? So increasing velocity, it's moving this way. So A to B, this is what the straight line I get in VT graph. Okay, and now from this point to this point, you observe, guys, this point to this point. See, it's a uniform velocity, right? It's uniform, right? It's a straight line. It's a curve. Curve always convert into straight line. If it is a straight line, you will represent it as parallel line to the t-axis, right? So, because you see from B to C, you have a straight solid line. That means from B to C, here you will have a parallel line. So, this is from B to C. And now C to D, you observe, guys, downward the parabola, right? So this is how you have inverted bowl. In the sense what? The velocity is actually decreasing. Velocity is decreasing, right? So that decreasing velocity, how do you represent? And remember, decreasing velocity, decreasing acceleration means velocity is negative. So here, if your curve is something like this, means V must be negative. It must be decreasing. Decreasing means sharp straight line to the bottom, isn't it? It must cross this t-axis because velocity is negative. When is your velocity can be negative? When it is below t-axis, when it can come below t-axis, right? So this is negative y-axis. So on y-axis you have V. So this is your negative y-axis. Velocity must become negative, right? Because you see, the curve is decreasing. From this point to this point, it is decreasing. That means, you know, the velocity must be decreasing. You have to show a straight line pointing like this. And it should be negative. Negative means little you have to drag below t-axis. Below t-axis. Right? Okay. And that's what is from C to D. This is from C to D. Okay. Now you observe from D to E, guys. Again, it's a straight line, right? Again, it's a straight line, but it is negative, right? Velocity is decreasing. So here, see, velocity decreases. Negative slope you will get. So in xt graph, slope of a line means velocity. So velocity is negative, you will get negative slope. So in the negative side only, since it's a straight line, you will show a line parallel to t-axis, right? See, this graph, this xt graph, if I transfer into vt graph, you know, with the same information, this is also talking about the motion of an object, and the same motion is described by vt graph also, but in a different way, right? So this is how you have to convert xt graph into vt graph and vt graph into xt graph. Okay, so I know this is not that very easy. You have to practice this. You must have fundamentals and more questions. When you practice, you will become perfect in this concept. Okay, but definitely understanding graph is really a very important thing to solve problems easily. Okay, so that's all about the chapter motion in straight line. Hope I have given enough justice for you. I covered all important concepts and I have shown you with the questions how to solve it and what concept to apply, right? So hope this has given enough benefit. Don't forget to post your opinion in the comment section. So see you with the next chapter. Thank you so much. Do subscribe our channel to learn the concepts in a easiest way and in a detailed way. All the best.